All right, so number 12. We're at number 12 now. We're not still on there. But anyway, and we'll continue because they'll get the video. The table below shows the values for functions f and the g. I think Andrew, you probably should remember this one. What? The value of g inverse of f of 3 is what? So just, I'll tell you, say if the function takes it from input, which the input values are always x, to the output value is y. The inverse function just reverse that process. So it takes it from the output back to the input. All right. So f of 3 is actually equal to 2. Right? So f of 3 from the table right here, when input is 3, output from the function f is 2. So I can just insert 2 in here. And now I want to know what g inverse of 2 is. So when I do inverse now, all I'm doing is what? Reversing the process. I want to know what is going to give me. So I'm taking the input, putting it into reversing the process. Right? So g inverse of 2 takes me from here back to up here, from output to input. So what gives me 2 is 5. So g inverse of 2 is basically saying what input would have given me an output of 2. Right? What input would give me an output of 2? So the inverse function just reverses that. So what was my output, which was 2, now becomes the input. So the output of 2 now becomes the input. And whatever input would have given me that is the answers I'm searching for. All right, so what gives me an output of 2? X being 5. So the answer that I'm looking for is C. All right, input, output, input, output. Inverse function just turns all of that around. All right, so keep that in mind. So we're at now. Question 13. Question 13, the value of x satisfies the inequality R what and what. Alright. Always remember that when it is less than, we're talking about the space, the distance from 0.
Sorry, hold on there. I miss 12 answer while ago.
5. Well, I recording this camera, so you'll get to see it again, but I can't go back up still.
No, I'm just say how I will answer for 12.
5. C.
5. Alright.
That. I'm still not asking you work. Get 5. But...
What was that?
Still not asking you work to get 5.
Oh, I get the 5?
Yeah, because work it like 3 different times. I'm still going to get the answer.
I'm saying you have the table, so we're not calculating anything. We're just interpreting the table. So whatever is inside here, inside the bracket, is usually the input, right? If you just think of it that way, a function, you have input that leads to output, plain and simple, right? So when I do f of 3, I'm looking at the function name, which function? The function f, which is this table, right?
3 is...
Now, what's the input? The input into f is going to be 3. Which part of this table is input? The top half of the table.
Yes, sir.
So when I input 3 into the function f, what is the output?
2.
2. So f of 3 is 2.
2.
So I put the 2 there.
Of...
So when I want to, that now is going to be into the function now, g inverse. There's no g inverse function on the table per se, but there's a function for g. So for g, which is this table right here, input gives me these respective outputs. But what the inverse function does is just turn that around. So what is output now becomes input, and what is input now becomes output. So if I do G inverse,
Of 2, I get 5.
yes, the input is now what? The 2, and what is the output that it gives me?
Oh, 5.
5, is that? So the G inverse just turn around the roles of input and output. That's pretty much, that's a simple way of explaining it. Do you understand now? A little better?
Yes, sir.
All right, good. So let me go back down to 12, 13 actually. So the values of x that satisfy the inequality is what? So I was saying for these now, a number line is always a nice way to use to explain. Right in the middle, let's say 0. So we're saying that the absolute value of something is what? In this case, it's what? More than something else, right? Let's just use an upper and lower boundary here. When you say the absolute value is greater than, we're talking about outside here, which means the absolute distance from 0 is more than a certain amount, whichever direction we're going. So we're doing greater than, right? So we're talking about outside here. So let's just say this was x. So if have an absolute value down here, so that would be negative x, so that would be positive x. So we're looking at everything that is more than x and everything that is what? Less than negative x. All of it just break this down and solve that. So to compare this is the thing. So we're gonna say 2x something there is gonna be what? So 2x minus a. So one expression is going to be, let me do it right over here. 2x minus a is going to be in one case less than negative x, and in the other case, which is on the right hand side, 2x minus a is going to be what? More than the x. I will just solve them individually and look for the answer. So if I'm solving the left hand side, bring this negative x across, it's going to turn to positive. So add that to that 2x, I'm going to have 3x here. And this a is going to come over, so it's going to be 3x is less than a positive a. And if I divide through by that, I'm going to divide both sides by 3. So one instance is going to be what? X is going to be less than a over 3. X less than a over 3. So x less than a over 3. You see anything else x less than a over 3? So we're down to either a or c. Because the other x less than a over 3 are here. So we have a or c. So we're going to eliminate. So I'll just solve over here now to get the other answer. So if you solve this, this x comes over as a subtraction now. So it becomes 2x minus x. That's just x. And this a goes over. We're going to go from negative to positive. So we're looking for x greater than a. So therefore, the answer we're searching for is going to be
sir, you can go over the left hand side. Go back over the left hand side. If you can go back over the left hand side.
2x minus a is less than negative x. So anything on this side of the absolute value is negative, right? Because 0 is in the middle. The positives here, negatives on that side. So if we're talking about the absolute distance is more than x, we just need to set up where x would be, and that means they're either in this space or in that space. On the left hand side, like you said, is being less than negative x. So I take this entire statement 2x minus a and write that it is less than negative x. And now I just go to solve. This is negative, so just like if you had an equal sign, goes over, turn from negative to positive. So I add 2x plus the x gives me 3x. This negative a goes over, so I change from negative to positive. And 3x, and then I solve, we get that. Over here, same thing. This comes over negative, so 2x minus x becomes 1x. Negative a goes over, it becomes. Answer is that. Alright, guys, I'm having rain, or you can hear the clouds from now on. I hope it doesn't happen, but it is very likely that this could light can go. So let me make sure the first half, let me save it properly. So just in case it cuts out, I would actually I need to have the first set of recording to send to you guys. So just give me 1 sec. Let me go into that. And just properly somewhere where I can find it in the light cuts out. And my laptop goes.
Sir, may I hear you from my side too, sir?
Huh?
May I hear you close them up on my side here?
Yeah. So, GPS once light red start fall, these things just computer sees upon.
Well.
Which paper? It's 2018 paper. Hmm. 2018 party. Alright, so at least that should be there when I'm a laptop cut off on that. Alright, so let's continue now. That has done. So we got the answer for this one. What was that? A, right? So it was A. Alright, let me push on. So we're looking at 14 and 15. And that should complete module 1.
What is that?
Alright, let's talk about this already. So the general equation, there are cubic equation roots alpha and beta and gamma may be written as, remember I said minus plus minus. So looking for that first. Minus plus, so it's not that, minus plus minus, alright? So first thing must be the sum of the root. The second one must be the sum of the pairs. The third one must be the product of the roots. So we found the answer. Answer is B. Alright, answer is B. Alright, so we'll not check the rest of it. And number 15. Oh, okay, that's all.
Hold on, let me just miss something.
The statement is logically equivalent to which one? To answer this question, I just have to try to speak a little louder because I know there's more noise on that. Again, you have the table for this. Alright? And you can do that on your own time. And I don't know what the answer is. I didn't do it before. But you can do the table and verify it. 1 second, please. Great, I'm blowing.
Difficult. Ring. Unfortunately.
Alright, sir. Yeah, move on to round 15. Seeing as we have for TV too.
Where the hell am I? Anybody get 13? What 13?
13 A.
A. I have 3. Yes, you never need to. That's very thing.
All right, I'm back. Sorry about that. Okay, so I think we completed the first 16 there. So that should cover module 1. So let's go into part 2. Which will cover what? Circles, vectors, and trigonometry. All right, so question 16. A circle is defined as such. The gradient of the normal to the circle at 0, 0 is 1. Gradient to the normal.
I want to answer 15. Sir, I want to answer 15.
Huh?
You did answer 15?
Answer for what?
15. You did answer 15 already?
No, we're going to that now.
But you are talking about 16.
So the question says the circle is defined by this equation. They want to know what the gradient at the normal circle at this point. So this is a point on the circle. So all you need to know is, and if I do a diagram here, you just want to know what the coordinates of the center is. So if I put a circle here, for example, this was a circle. Not really worry about where the x and y axis is. The point is, it's not centered at the origin. There would be a point somewhere on here. So let's just say, for example, this was the point on the circumference. Let's just say this is the point that they give us 0, 0. And you need the center, say do a line from the center to that point, and the equation of that will be the gradient of the norm. So that's what the center, this is the norm. This is what we would refer to as the norm. All right, and so we need 2 points. So you need the center of the circle and that point which is given, and then once you find the gradient of that, and that's what you do. All right, so just to point that out, what with the center of this circle? Remember the equation was x minus h plus y minus k, and hk is the coordinate. So the center of this circle would be -2, 0. Now the k value is 0. There's no change here. So -2, 0 is 1 point, and the other point is 0, 0. So you could easily find the slope of a line like that. Changing y over changing rise over run. Right? There's no rise, there's no change in y. So it's 0 over run is 2, -2. Really doesn't matter what the run is. Right? Rise over run, 0 divided by any number is going to be 0. All right? So the answer for 16 is clearly C. All right? Number 17. So point to that, the main part of that one is to get 2 points. So they always give you one on the circumference, so you are now have to find the center of the circle. Once you do that, then you're good. The value of sine of pi over 2 minus p is what? These are the things you should know.
Pi over 2. Pi over 2. This is like 1 rotation.
Cosine of any angle is same as sine of 90 minus that angle. But again, you can use the double angle identity to work this out. That's a little longer, but the answer is going to be A. Well, let me So this is something to know. Cosine of 30. And this is all something I remember. This is all my reference point. Cosine of 30 is the same as sine of 60. And so if I take away 30 from 90, I get 60. So it always works hand in hand like that. So that's always something that I remember. Now, what you guys need to remember, which is helpful for probably what is going to come later, is to know the double angles. So this is A and B. The sine of A plus B and sine of minus B. So in this case, added A minus B. So sine of A minus B is what? Sine is one that switch. So it's going to be sine A is pi over 2. So it's going to be sine of pi over 2. Sine A cos B is going to be cosine of B. Whatever sine is here, the same sign is minus, and then switch them. Sine P cos A. Sine P now cosine pi over 2. So that is the double angle that you must always remember. So this is very beneficial for, I'm sure we're probably going to use this again before the question starts. Alright, so now you need to remember what sine and cosine of pi over 2 are. So you need to remember the unit circle. And just need to remember one quadrant actually. Right, is at 0 degrees. Here so is 90 degrees of pi over 2. Well, you need to remember this. And then you have 30 degrees, 45 degrees, 60 degrees. And it's always 1, 2, 3 on the inside, 1, 2, 3 on the outside, and everybody square root them and it's over 2. So, but we only need to focus on the 90 here. The coordinate for this point is what? 0 for x, 1 for y. First term is always cosine. Second one is sine. So cosine of pi over 2 is 0. So this is actually equal to 0. This is equal to 1. Alright? So 0 times anything is 0. So 0 times sine p, all that is gone. So 0. 1 times cosine p will give me cosine p. So we already said the answer is cosine p, but this is another way to show. Alright? So 1 times something is the thing. Alright? So the answer does end up to be cosine p by itself. Right? So you need to remember the side, the double angle added to. Alright? After remember that, or you have to. Let's continue. Number 18. Line through the point PK, 2, and this is parallel to the line of the equation such and such. What is the value of K? Alright. To get 2 points, one of the coordinates is missing. So that's what they asked me to find. So that's okay. We get another equation, and they tell that they are parallel. So the fact they're parallel means that they have the same slope. So all we need is the slope from the first line here, and then work this out so that it's equal to that. So if we were to simply rewrite this equation, Landy, if we were to rewrite this equation, y equal mx plus b, if we want to write it in that form, y is going to simply be equal to
2.
This is going to go over, become negative 3x, and negative 21 goes over and becomes plus 21. So the equation on the line is this. What is the slope? The slope is negative 3. Negative 3 is this number that's going to help us to work out this question. Right, not the answer, just helping us to work out the question. Now, when we use these 2 points, the slope of this line through P and Q, must have a slope of -3. So just have to apply rise or run with this. So if we do difference in this, 8 minus 2, that is 6, over, that's rise or run, 6 minus K. So 6 over 6 minus K must be equal to -3. That's what we're trying to solve. So 6 divided by some number must give me -3. So that's not so hard. If I speak it out like that, that's easy. 6 divided by a number must give me -3. What is that number? So what number can I divide into 6 to get me -3? That's going to be -2. Right? So that means my denominator here simply needs to equal to -2. So 6 minus a number must now take me to -2. What is that number? And that number is simply 8. 6 minus 4 will give me +2, but I want to get -2. 6 minus a number gives me -2. So if K is 8, my denominator is -2, my denominator is -2, divide the 6 and give me -3, which is what I'm looking for. Hope you can figure that out. All right, so the key to the question was to rewrite this equation first, so we could identify what the slope is. And the fact that they are parallel means that the slopes are the same. They could have given a question like that and say, not parallel, but perpendicular. And it was perpendicular, it therefore means that the slope of this line would be the negative reciprocal of it. So if it was a perpendicular question, we'd be looking for a slope of +1/3. If it was perpendicular. All right, the fact that them says parallel means that the slope are equal. So that's why I put -3 here. If they had said perpendicular, I would not put -3, it would have been +1/3. So 6 over 6K would have equal to +1/3. It was perpendicular. So I hope you understand. So move on. So going to 19. The gradient of the straight line perpendicular to this. So see, go on to that same concept now. And I hinted that it a while ago. Now we into it. The gradient of a line which is perpendicular to this line is what? So we just need to first figure out the slope of this line. So we need to write this in terms of y equals mx plus b. So you're gonna bring these guys over here, leave 2y here. So if I were to rewrite this, it's gonna look like this. Y is gonna be equal to, and I'm doing about the same.
And the no, because it was in there. It was in.
All right, back. So we want to write this in the form y equals mx plus b. So I'm going to bring all of these over and also divide them by 2. So and I have 2y, this would have gone over as 3x. And it will be 3x, -3x at that, I'm sorry, -3x minus 4. But then we end up dividing all them by 2. So it's going to be over 2. It's over 2. But they only care for the gradient of the line. So this is the slope of this line. Now we want the line perpendicular to this. So it is the negative reciprocal. So the negative reciprocal is negative of a negative is positive, and reciprocate this, it is 2 over 3. So we're looking for 2/3. That is it. Okay? So just give me next 10-minute warning again. So yeah, that's good. All right. So number 20 says what? A curve is defined by the parametric equation, and they want the Cartesian equation, which simply put is just to eliminate the parameter, right? So everything's into x and y. So all of these are solve either one of these for t and substitute into the next. So use a simple equation. If I want to solve this for t, t would simply be equal to, bring the 2 over there, t would be equal to y minus 2. Alright? And then I'm going to solve this t, substitute this t into x. So if I put y minus 2 here where t is, this is now going to be x is going to be equal to 3 plus 2t, but t is all it is. It's going to be 2 times y is 2y minus 2 times this 2 is going to be 4. So I just need to simplify all of this. It's going to be 2y, and 3 minus 4 is negative 1. So I'm looking for 2y minus 1.
Carrot. Oh, says it's
No, all right. So then want to look at it this way. So which one is the current? I keep the x, bring the y over there. So this is positive, then turn to negative, then the minus 2y. So x minus 2y, and that's going to be equal to 3 minus 4, negative 1. So now I see the answer. Being D. Okay? That's how we do that. Those two questions. Okay, that's moving down to 20. What value of theta, where theta exists between 0 and pi, which is from 0 to 180 degrees, satisfies this equation right here. So this is a quadratic equation. If I do a simple substitution like this, if I let cosine, if I do cosine of theta, if I let cosine theta equal to, let's say, x, I can rewrite this equation much easier. This is going to become 2x squared plus 3x minus 2 equals 0. Simple quadratic equation that I can factor out. So 2 numbers multiplied give me that. If I factorize this, we need to know how to factorize. This is a prime number. The only way to get that is 2 in one bracket and 1 in the other bracket. So 2 is a prime. So that makes my factoring easier. And this last number, these 2 numbers must multiply and give me that as well. And again, this is also prime. And I couldn't put 2 here because 2 would be common with this 2, which implies that over here would have 1 actually. And over here would have the 2. You have to figure out what sign goes inside each other. So now I want the middle term to be positive, which means that the larger product must be positive. So 2 times 2 is greater than 1 times 1. Therefore, this gets plus, this gets minus. 2 by 2 is positive 4. That is negative 1. 4 minus 1 gives me positive 3. So that is what I'm looking for. Now, this is factor, which means these are what we have to solve. So from here, x would equal to what? This bracket x would be equal to positive a half. Change the sign, divided by that. Over here, x would equal to negative 2. Now, cosine of an angle being negative 2, cosine exists between 1 and negative 1. So we can eliminate, we don't have to look at this one. So we only need to focus on this solution. So cosine of what number equals to a half? And again, if you want to know, you can go back to the same unit circle I tell you. There's always three angles in there, 60, 45, 30, not to even draw them with this. But the coordinates go like this. 1 over 2, 2 over 2. So numerators count down. 1, 2, and 3. 3 over 2. And you square root all of them. So root 3, root 2. But square root of 1 is 1, so we can't leave it at that. And then the y values for them go up the way. So 1 over 2, 2 over 2, and 3 over 2. And then square root all the numerators like that. So there's root 3, root 2, root 1 is 1. Alright? And again, same thing. So we're looking for cosine being equal to a half. Cosine is always the first term. So that means this angle is 60 degrees. So which one of these represents 60? Pi over 3 is 60 degrees. Because 3 of them must equal to 180. So you multiply by 3. 3's cancel, you get pi. 3 times 6 will give you 180. So just to verify that. Pi over 3 is in fact 60 degrees. Pi over 6 is 30 degrees. Pi over 4 is 45. Pi over 2 is 90. So that is the answer we're looking for. See right there. Alright, so clear that. 2 minutes and then this cuts off. So let's see what more we can do before it finishes. So we're at 21. The expression cotangent. Oh, we did do this too. Expression cotangent of x plus tangent of x can be written as this one is to go into some writing, and see that's why I made tell you so must come to class now. All of these were done at school. Alright, how we have to break this down. Cotangent is the inverse of tangent. Tangent, let me start with tangent. Tangent is sine over cosine. So this is sine over cosine. So that means the cotangent is the inverse of this, so flip this is cosine over sine. Right? And then now we're saying that if we add these two together, it's equivalent to which one of these down here. So when you add these, just like how we generally add fraction, you crisscross, so cos times cos is cos squared. So that's cos squared. Remember the x is always there, and then sine times sine, that is plus sine squared. And the denominator is going to be sine times cosine. So it's going to be all over sine times cos. Or cos times sine, it really matters. Sine times cosine. Now, you'd like it to think it's this, but it's not because these are squared. And the identity for cos squared plus sine squared is actually equal to 1. This is really 1 over sine something cos something. It's all cut off in a minute. All right,